Hello math learners! Welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash. And today, we're going to discuss the last operation on radicals. And that is all about division of radicals. In this video, you will learn how to properly divide radical expressions as well as follow the rationalization process. If you don't know anything about this, then I suggest you finish this video. But before anything else, hit that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for quarter 2 of the grade 9 mathematics, which is all about division of radicals or dividing radical expressions. The question is, how do we divide radical expression? Basically, when you divide radical expressions, you just apply what you have learned in the law of radicals in terms of dividing radicals. And that is by the process of applying the rule number 3. Now, remember always that your final answers should not have a radical expression or radical symbol in the denominator side. So, if in any case, your final answer has a radical expression in the denominator side, then you will apply the rationalization, which is the fifth rule. So, let us start answering the given problems on our whiteboard for you to understand the steps in dividing radical expressions. Okay, we have number 1, square root of 7 divided by square root of 3. Now, remember that 7 is not divisible by 3. Now, if you cannot simplify it even further, then that is it. However, remember that this violates our rule. We cannot leave a final answer with a denominator that has a radical expression. If that is the case, then what we can do is we just apply our rationalization and multiply the whole fraction with the needed number for this denominator to become a perfect square. Now, what is a number needed for the square root of 3 to become a perfect square? And that is square root of 3, because 3 times 3 will become positive 9, and that is a perfect square. Okay, so if you multiply square root of 3 in the denominator, you also multiply square root of 3 in the numerator so that the whole value will become balanced. Okay, so by doing so, square root of 7 times square root of 3, that will give us square root of 21. Square root of 3 times square root of 3, that will give us square root of 9. And if we simplify it, this will become square root of 21 over 3. Easy, right? So that is now your final answer. Okay, so let's go to our second example. Now, for our second example, we have square root of 15 over square root of 6x. Now, 15 and 6 are both divisible by 3. So what we can do is we can combine them into a one radical expression, and that will give us 15 over 6x. If we simplify this, 15 over 6, using the lowest term, we will have 5 over 2x. Now, having this one, square root of 5 and square root of 2x, they are both not perfect square, but our denominator has a square root symbol. So basically, what we can do here is we go back this to a separate radical expression, and then we apply our rationalization, just like what we did here in our first example. So what we do is square root of 5 over square root of 2x will be multiplied to the number needed for 2x to become a perfect square, and that is still square root of 2x. So if you multiply to the denominator, you also multiply to the numerator. So square root of 5 times square root of 2x, that will give you square root of 10x. Square root of 2x times square root of 2x, that will become square root of 4x squared. If you simplify this, this will become square root of 10x, and in the denominator side will become positive 2x, and that will be your final answer. Now, as you can see, my dear math learners, you might be asking, and one of the confusions of the students is that if they see an x here and another x here, they will crash that out. My dear math learners, do not do that. Or they will just divide 10 and 2. My dear math learners, do not also do that, because this is an expression without a radical symbol, while this is a number inside the radical symbol. So in this case, they are not like terms. So please do not do anything about this one. Okay? Just remember, your final answer should not have a radical expression or radical symbol in the denominator side. Okay? I hope you got that, my dear math learners. Now, let us go here. We have 5x square root of 11 over 2 square root of 10x. Now, as you can see, my dear math learners, 11 cannot be divided by 10, as well as 5x cannot be divided by 2. So, how do we do this one? If this is the case, this is already simplified. Okay? However, we have a denominator with a radical sign here. So, what we can do is we will multiply it to the radical expression to become a perfect square. Or, in other words, we will just rationalize this one. So, how do we do that? We will multiply 10x in the denominator and another square root of 10x in the numerator, giving us 5x, 11 times 10, that will give us 110x over 2 times 10 times 10, that is square root of 100 x squared. And if we simplify this one, that will give us 5x square root of 110x over 2 times 10x, because I just copied this one, I just copied the numerator, while I simplified square root of 100x squared, and that is 10x. Simplifying it will give me 5x over 110x, square root of 110x, 2 times 10, that is 20x. Now, as you can see, my dear math learners, this is a coefficient, this is also a coefficient, and we can simplify this one. They are outside the radical expression. So, by doing so, 5 and 20, we can get the lowest term, and that is 1/4. Okay? So, that will give us 1/4. So, 1/4. Okay? And then x and x can be cancelled. So, in this case, we can cancel them because they are both outside the radical expression. So, we have 1 square root of 110x over 4. So, I'll just write the 4 in the middle. And since any radical expression without a value here is automatically has a coefficient of 1, I'll just delete this one, and this will be your final answer. Easy, right? Now, let us go to our fourth example. Okay, math learners, for our fourth example, we have 6 cube root of 7 over cube root of 3x. Okay? So, basically, 7 and 3x are the thing that can be simplified here, but we cannot divide them because 7 is not divisible by 3. Okay? So, what we can do is we just apply our rationalization. So, let's just eliminate the cube root here. So, what we can do here is we will multiply. Now, we are talking about cube root. What is the needed of 3 to become a perfect cube? Okay. Remember that in the perfect cube, we have 1, we have 8, we have 27, and so on and so forth. So, 27 is the least number that in which 3 is divisible. So, what is needed for 3 to become 27? That is the cube root of 9. Now, we have x. In order for this to become a perfect cube, it needs to become x cubed. So, what is needed of x to become x cubed? That is x squared. So, in the same case, we will just multiply it to our numerator. Easy, right? Now, let us simplify. 6, okay, let's just copy that one. Both are in the radical sign, so we will have cube root of 7 times 9, that is 63. Then we have x squared. Okay, over 3 times 9, that is the cube root of 27x cubed, because x times x squared is x cubed. Now, by simplifying, we have 6 cube root of 63x squared over 3x. Because the cube root of 27 is 3 and the cube root of x cubed is x. Now, as you can see, in the outside, we have 6 and 3. So, we can simplify this one. So, 6 divided by 3, that is 2. However, there is an x here, so the x will remain in the denominator side, giving us 2 cube root of 63x squared x. And this will be your final answer. Easy, right? Now, let us go to our final example. Okay, math learners, we are down to our final example. So, what we can do here is we are having a powers of 4. So, the fourth root. Okay. Is 3 divisible by 4? Okay, no. So therefore, we cannot divide 3 to 4. However, our x and x here can be cancelled out. So what we can do now is we just write 5x squared and then the fourth root of 3, because this will be cancelled, but there is still 1x to be left in the denominator side, 4x. Now, the question is this our final answer? Not yet, my dear math learners. Why? Because our denominator has a radical symbol. So, therefore, we need to eliminate it by using the rationalization. So, what is needed by 4 to become a perfect power of 4? So, let's just write the fourth root. Let's just write the fourth root. Okay. Now, remember that 4 can be broken down into 2 squared. So, it is not yet in the power of 4. It needs another 2 squared in order for this to become 2 to the 4th. So, remember, if this is 4, this is also 4, so it needs another 4. Okay, so that is also here. Now, we have x. What is needed by x to become a perfect power of 4? Of course, it needs 3 more x's, and that is x cubed. So, we have x cubed, x cubed. Okay. So, our final answer would become 5x squared. Okay, I will just write this one. And then we multiply this. This will become 4th root of 12x cubed over 4 times 4, that is 16. The 4th root of 16x to the 4th. So, this is a perfect power of 4. So, we will be simplifying that one. So, that is 12x cubed. Okay. So, that is, the 4th root of 16 is 2. The 4th root of x to the 4th is x. Now, can we still simplify this expression? Okay, we can still simplify this because x here is outside, x is also outside. We can cancel them, so that will become 5x, 4th root of 12x cubed over 2. And that will be your final answer. Easy, right? So remember, my dear math learners, that in dividing radical expression, if in any case you cannot divide the numerator and the denominator, and you think that this is already simplified, always look at the rule of the radical expression such that it is prohibited to have a radical expression or radical symbol in the denominator side. So if that is the case, what you need to do is to apply the rationalization. Okay? So, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time in learning how to divide radical expression. This is still your free access math teacher, Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you so much for subscribing, liking this video, and sharing this to your fellow friends, classmates, and schoolmates. If you do have some questions to our discussions, feel free to put your inquiries in our comment section below. God bless, take care, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click the subscribe button and notification bell. Thank you.